At the boundaries between the Earth's crustal plates, whether zones of subduction, sites of ocean floor spreading, or faults where plates slip past each other, the crust is under a tremendous amount of stress. As a result, it is in these locations that most of the volcanoes and earthquakes of the world occur. Many of the world's approximately 600 active volcanoes are located in almost continuous circle around the edge of the Pacific Ocean. This area is also the site of frequent earthquakes. As a result of the pattern of volcanic and seismic activity that occurs there, scientists have named this volatile region the Ring of Fire. In Activity 12, students create a map of the Ring of Fire and relate the location of volcanoes and earthquakes to the boundaries between the crustal plates. This activity will take about 40 minutes. The vocabulary introduced in this activity is Ring of Fire. For this activity from the kit, you will need the plate puzzle pieces from Activity 6. In addition to the kit materials, you will also need to supply black crayons or markers, 2 other colors of crayons or markers, and a world map. Make copies of Activity Sheet 10 for each student. As in the last activity, students again look at the reassembled puzzles from Activity 6. Ask students where magma is likely to rise up into the crust and where large sections of the Earth's crust slide past each other. Responses should be at the boundaries between crustal plates. Divide the class into teams of 4. Give each student a copy of Activity Sheet 10 and several different colored crayons. Any colors will do except black. Use Figure 12.1 and a map of the world to guide the students as they plot the major sites of volcanic and seismic activity on the map on Activity Sheet 10. Have students fill in the key at the bottom of the activity sheet indicating what each symbol and color represent. Johanna, let's see if we can try plotting a few of these locations on your map. We need to finish our key. I see you've already chosen the blue circle for earthquake. What do you think you want to use for volcano?
Oh, we're going to use a triangle, and you're going to use green.
Okay, I'm going to look at my teacher guide map, and we're going to start in North America, and I see that on my world map, then I can find that location. And up in the northern part, right about right here, if you can find that on yours, we're going to plot a volcano.
Okay, so right about here?
Right about there.
Okay.
Yeah. Good. Okay, and then right down under it, we've also got another volcano. So if you want to put that right under it. And then if we come right on down that coastline, we have an earthquake. So if you want to mark an earthquake.
This looks like it might be around California.
And we could continue on with the rest of the ones that are marked like on my worksheet. After we finish plotting, we want to have students study their colored map and ask them to comment on any patterns they may see. Allow time for them to make comparisons of their colored maps to their plate puzzles. Explain that mapping the location of earthquakes and volcanoes led scientists to see that something very significant was happening along plate boundaries. This information supported the theory of plate tectonics. Once they understood this, they could see that volcanoes and earthquakes occur where crust is being created or destroyed. Write the phrase Ring of Fire and tell students that this is the name for the pattern of volcanoes and earthquakes that can be seen around the rim of the Pacific Ocean. To help students connect the relationship, ask a series of questions such as, why do you think it is called the Ring of Fire? At what kind of plate boundaries are many volcanoes located? What happens when an oceanic plate collides with a continental plate? Why do you think volcanoes occur at these plate boundaries? Explain that mapping the location of volcanoes is one of the methods scientists use to locate plate boundaries. For cleanup, students may keep their puzzle plates if they like. Guide the students through reading page 11 in the Delta Science Reader.